So my name is Gerard O'Grady. I'm from Open Horizon. It's a venture platform, and basically the thesis is that we run outside in terms of tech development, and that means we come up with the actual technology first, and then we recruit the actual management team and development teams around that. Yeah, well, deep learning has reached a level of maturity that is being driven basically by the amount of data that's out there at the moment, and also by the power of GPUs, graphical processing units. And we're seeing a lot of powerful libraries out there, such as TensorFlow by Google. And what we're seeing now is a lot of applications of deep learning algorithms and processes into a lot of industries that would typically not have seen that beforehand. Well, it's actually taking away the visual aspect of it, because the point about the augmented analytics is that from its the traditional form or legacy form of analytics was actually a data scientist looking at a massive data and working out insights, getting insights, and then translating that to actionable data. But there's a problem with that, and basically, first problem is it's very hard to build a scalable data science team. They're hard to come by. It's a HR problem. Secondly, data scientists are not business executives, so you've still got that communication problem in trying to actually get the data learnings that they're coming across across to management, and that always gets lost in translation essentially, and they're not exactly sure what they're looking for. Another problem is naturally they're only human, so data scientists can only look at 10% of the data that's out there, so they might be missing other insights that lie within 90% of the rest of the data that's there. And secondly, speed. If you're running a deep learning algorithm or process on your data, well then that actually it speeds things up. But I guess the link into the augmented analytics aspect is that it provides actionable insight. So it doesn't just provide data saying, okay, our revenue's gone down 10%. It will actually start looking at the actual triggers for that happening, and providing prompts. For example, there could be an advertising metric that's going down, or it could be a production metric, or it could be a distribution metric. So it will actually provide actionable insights to management. So it will actually close the loop essentially there. I mean, blockchain, it has got some amazing strengths. I mean, it's been called the next evolution of databases, like what SQL was back in the 70s. It's now, this is an open source, distributed database that is immutable, that can be trusted, and it's not prone to attack. But it has problems, and one of the problems is the computational power is very low at the moment. Like if you were to try to run a commerce financial application on it, it wouldn't be able to process a credit card transactions fast enough. It's like thousands of times slower than the legacy systems that, say, Visa would use. So the solutions around that is building out the blockchain stack to, say, side chains, running applications of the actual chain itself, and integrating them, and so using blockchain as, say, a version control system or the spine of the actual system. An example of that we're actually using would be, say, healthcare records, and there's like over 1,000 EMRs out there, that's electronic medical records, and we're using blockchain to synchronize the data in those and maintaining version control, because although governments and insurance payers in the US, for example, would like to have a very big design upfront process and rollout, it's not really realistic. So you're not going to be able to go to all the different hospitals. I mean, even in Ireland, some of the hospitals have 20 different EMRs across the different departments. So blockchain is a great way of actually synchronizing all that data and allowing you to establish a middleware system that is more easily accessible. Yeah, automation is going to be a big changer moving forward, and obviously there's great technological opportunities, but there's also social challenges and impacts, and I think there's a lot of nervousness out there in terms of the actual what's going to happen in relation to that. But I think automation will certainly replace a certain number of jobs, but they will be sort of low-level jobs, and they will, but at the same time, will create better, higher quality jobs. To give an example, you were mentioning the automotive industry. Example of automation would be obviously a car being able to navigate itself through the road, the streets, and so forth. I think we're all familiar with that model. That's a sort of machine vision, actually deep learning model. But another aspect of automation is actually where the individual machines themselves or the intelligences are actually connected in a collective or a swarm environment. So to extend the automotive analogy would be, navigating cars through the city. So make sure traffic flow is moving well. It could be shipping, logistics, and so forth. So I think a key point with automation is going to be that sort of distributed but yet centrally intelligent swarming mentality. So another example would be smart cities. You could have systems that are looking for failures in utilities, power supply, or infrastructure, for example, potholes in roads or cables that have fallen, and then that would actually trigger some automated process to actually repair the problem. Yeah, well, digital twins is basically a connection between the physical objects and creating a virtual analog, basically. So it's like simulating a device. So you mentioned AutoCAD, which is a good example, because you could almost say that's the prototype of a digital twin. Although it doesn't do much, the difference between a proper bona fide digital twin model as we know it today is basically that they model the actual elements and the actual usage of the actual device itself in the environment. So for example, that could be monitoring the components of a jet engine, or it could be monitoring, say, the operations in an enterprise architecture. I mean, that's really where you're doing real-time deep learning. You're just seeing the actual applications in their actual environment, and they can be different. So the key thing is with deep learning is that it would allow you to actually run the digital twin in different environments. An example of that would be, let's take the jet turbine engine that we were talking about just a little bit earlier. Running that in, say, an environment on, say, a flight route that is, say, up in the Nordics, it's exposed to cold, sleet, so forth, could be very different to a digital twin simulation that's been running in, say, the Middle East, and it's exposed to sunlight, UV rays, and sand, and so forth, and other contaminants. So basically that allows the operators of those engines to actually start predicting performance and predicting when there might be a failure on the actual components. But it also allows the manufacturers to refine the actual product itself. So, which is another sort of trend that we're seeing, is that more customized production of items. It's the beauty of it, as I was saying again earlier, like it's the rapid development aspect, and that's why we see Python cropping up in a lot of cutting edge technology. So, I mean, the advice would be to any developer out there looking to get into the game would be, well, if you know Python well, you'll be able to transition to a lot of exciting areas. Like, I mean, we're seeing Python catching, and the maturity is coming there as well. It's not just a first language, but it's also a language for life. We're seeing Python catching up with data scientist-based languages like R in terms of its capabilities. And again, as we're saying, the community is just constantly growing, and that only leads to better libraries, and that is really the fundamental way that software is developed these days.